And thank you for joining. Please, Roderik, the floor is yours.
Okay, thank you very much, Gael. For those who were at the Protect meeting in Grenoble, I guess if they have a good memory, they can go for a coffee, because I thought for those who were not there that I have to repeat what I told there essentially. But in this case, of course, the main emphasis, if it's up to me, will be on having a discussion on how Protect can bring this work further during the period which rests for Protect. And I just understood from Gael that there's still some time to go. So I think it may be worthwhile if Protect can come up with the revision of this work towards the end of the project. And for that reason, it's useful to have the discussion now, I think. So I dubbed at that time, when I gave the presentation in the Protect meeting, was it 1 month ago, I think, from HIL to HELP, where HIL stands for the high impact, low likelihood, which is the approach taken by the IPCC AR6 report, and HELP is the approach which was taken by the WCRP Grand Challenge team, and that consists of where is it? Of many people, and most of them are on this slide, and I think I saw several of you also online. So it's a group of people who have been invited to contribute to getting a high-end number for sea level change for different scenarios and for different timescales. And just as an illustration, the high end, I'll come to a better definition in a minute, but that's outside the likely range. And recently there has also been made a compilation by essentially authors from AR6, AR5 and SROC on differences in the projections for the different reports. And if you look to this figure, you can clearly see that, in fact, the likely range, well, maybe you could say that's kind of settled discussion over the last 10 years. There's not that much difference between the different reports, but you also clearly see with these gray bars that outside the likely range, there is quite some discussion ongoing, which is not settled, I think. And that particularly focus on the contribution from Antarctica and Greenland, as you can see, particularly for the SSP 5.8.5 scenario. So the high end of the trend is outside the likely range. It's not a precisely defined probability, but it's also not the highest value you can get by melting all the ice immediately. So maybe a little more formal definition could be the high end of the sea level projection uses multiple lines of evidence. So this is very much based on this concept of storyline approach. And it also, in our view, should include the physical plausibility to constrain the estimates of critical processes contributing to sea level rise. In other words, we would like to have a projection of sea level rise which is explicitly based on our physical understanding of the system, and that is an additional starting point to get to a high-end projection, I think. And that is what we did. So we assessed all the existing literature, and we came to high-end values for all the different components of sea level rise. So just to recall that there is not a very simple way to make projections of sea level rise, because Earth system models barely contain the ice component. It's coming. Their first attempts are there, but it's not like that sea level is one of the variables in the Earth system models. Maybe in 5 years from now, but maybe in 10 years from now, who will know? So we have to do something else, and there has been, of course, attempts to this earlier on, and IPCC in the past used deterministic ice sheet models based on AOGCM output, and probabilistic approaches have been attempted, structured expert judgment has been attempted, and quite some time ago there was this kinematic approach by Ted Pfeffer. So these are all, you could say, attempts to get to a value for sea level projections outside the likely range. But in this case, we more follow what was proposed by Ted Shepard in 2019, self-consistent, plausible pathways to get to sea level projections. And just as a comparison, the AR6 approach, which you've all seen. So in the colored lines at the bottom of the figure, I'm not sure whether you see my mouse moving. Is that the case or not? Can somebody confirm?
Yes, we
okay.
see.
These are the likely range projections, and the discussion, of course, is outside the likely range, because it does it go up to this dotted line, or does it go somewhere else? And that's well, not an issue for the short timescales, but already in 2100 you see an enormous divergence between the low likelihood, high impact storyline from AR6 and the medium values. And that, of course, gets worse if time progresses and if you make projections up to 2300. So the physical reasoning we followed for glaciers, expressed by these icons, is very much sensitivity on one hand, temperature change and precipitation changes leading to surface mass balance and eventually leading to sea level. So we did follow particularly the cryospheric component, because the ocean component is not very interesting for the high end, because it's internally resolved by the Earth system models, and for that reason pretty well known, even the high end values. So there's no real problem there, but the cryospheric components you can discuss. So we first started with the glaciers. Then for Greenland, it already gets more complicated because there are several physical processes which are poorly constrained. There is uncertainty on how you should model the albedo and the circulation on top of the changes in temperature and accumulation and melt. So surface mass balance seems to be the most critical process, more than the uncertainty in the dynamics, but eventually, of course, you need the dynamics to get to sea level rise. And maybe the largest uncertainty arises for Greenland because of the possibility of tipping points which may be reached within the scenarios which we typically consider within the timescales we typically consider. But I think we cannot be very conclusive on that. So in the end, for Greenland, we concluded that the largest uncertainty is related to the combination of albedo feedbacks and atmospheric circulation changes, and that a reasonable estimate for the high end would be what ISMIP results showed multiplied with a factor 2, which then should accommodate the uncertainty in albedo and atmospheric circulation changes. So this is a point where we can come back to in the discussion, because that's, of course, a pretty ad hoc thing to do. But on the other hand, this is what has been published. So we have at least something to rely on. But maybe one can foresee that this can be quantified better with upcoming work from Protect or maybe from other sources. So for Antarctica, we also had a chain of physical processes, and clearly there, I think the largest uncertainty for a high-end projection lies in the fact that we need to come with a better timing of the ice shelf breakup, because as long as my mantra is always that as long as we have ice shelves, we can get some contribution from Antarctica, but not an extremely large value. The large values can only come by the time that the ice shelves are broken up, because then the rates are very poorly constrained because our limited understanding of the dynamics. So for Antarctica, I guess there are two sources of uncertainty. Can we get a better timing of ice shelf breakup, and can we constrain the dynamics? But as the first is not known, then the second doesn't play a role. And for that reason, I think ice shelf breakup is maybe something to focus on. So this is the reasoning for Antarctica, and I think it's slightly different than we traditionally did by having a very strong focus on the dynamics only. And then another issue which came up during all these discussions, and that's also a thing which we may give further thought in the near future, I guess, and that is related to the fact whether a high-end contribution for Antarctica is correlated to a high-end contribution for Greenland or not. And in principle, you can think about this from a process point of view. Are we discussing the same processes? And at the same time, we can also discuss whether the climate change is equally strong or important for Greenland as for Antarctica, depending on the quantity of interest. So there are various reasons why we cannot take for granted that the two components are completely correlated. At the other hand, it's also unlikely that they're completely uncorrelated. So for the time being in this approach, we offer two possibilities. One is they're completely independent, and the other one is they're completely correlated. And maybe we can have a discussion on whether this can be quantified, the covariance between the components. So in the end, we produced a set of values for 4 different scenarios, depending on timescale and on temperature change, whereas we roughly took the RCP 2.6 for the 2-degree scenario, and the RCP 8.5, and the extended RCP 8.5, the SSP 8.5, 8.5 for the 8 to 10 degree scenario. And then we had the 2 degrees of correlation, which was the perfect correlation and complete independency, which are at the bottom line. So that's makes how you add up the different components. And well, you can see that the difference between those 2 approaches diverges over time. So depending on how precisely you want to have your high-end values, this already gives quite some difference in 2100. And at the same time, if you have the numbers from AR6 in your head, you will notice that the values we find are, well, I'm not sure whether you should quite a bit or at least somewhat lower than what has been used or proposed in the IPCC report. So the differences between what we have in this paper and what is in the IPCC report is summarized for the 4 scenarios in this slide. So in fact, there is no or not much disagreement between the 2 approaches if you consider low scenarios and reasonably near future 2100. But if you take other scenarios, longer or stronger, then you get differences, and those differences are remarkably, in 2 cases, related to Greenland, and in 1 case, the high and long term, it is related to Antarctica, where we took, in fact, the average of 4 different dynamical studies to get to a high-end value, rather than taking a single study and trying to provide the high-end scenario for Antarctica, like was done in AR6. So by doing this, I think we have an alternative high-end estimate, which is transparent, physically based, using multiple lines of evidence, and thereby, according to practitioners, of greater practitioner value. And the consequences of this estimate are, of course, that there are, but that's not surprising, that follows from any estimate of high end, I would say, large differences in adaptation effort between 2 and 5 degrees. And of course, the low and high strongly diverge after 2100, which is related to the fact that the shelves are not disintegrating before 2100 in this reasoning. And well, there is always a lot of discussion on whether we can have 2 meters of global mean sea level rise in 2100. And in fact, we find very limited evidence for that in the physically based literature. So locally, it may be the case, because there are always local variations on top of the global mean. But for the global mean, 2 meters seems to be too high. And I think that is essentially what I wanted to recap. And the question, in fact, where this ends is whether this exercise should be repeated and the frequency when this should be done. But before that, I would like to list a couple of open ends as a starting point of the discussion, where we can have a discussion whether Protect can add there, or whether this approach should be refined, because I think you could argue that one of the on purpose shortcomings of this approach is that we only have 2.6 and 8.5, and I think there is a need for intermediate scenarios. The question is whether we have enough material to do that, and that reflects why we didn't do it in this approach, because it would require that you have more studies, I think, on intermediate scenarios than currently are available. This is upcoming, but well, I think you need a decent number of publications to come up with a high-end value. And well, I'm not sure whether that is currently already the case. I doubt, maybe. But there is one obvious weakness of this study, and at the same time an opportunity for further work. Another one, which is also a bit on purpose, is that we took 2100 and 2300, because the 2100 limit offers us the possibility to be reasonably sure that the sea level contribution from Antarctica, which is related to disappearance of ice shelves, is not yet playing a major role in the projections. And this is clearly not anymore the case in 2150, because there are a couple of studies suggesting major ice shelf loss right around 2100 or slightly after that. And that makes it pretty complicated to get good estimates in 2150. But there is clearly a request for that, so maybe we should also try to address that. And the same holds for 2200. And going to 2300 is, in a way, it's more easy, because then we can be pretty sure that under high-end emission scenarios, there is a major collapse of ice shelves and then we are, I think, reasonably sure that Antarctica will contribute an enormous amount to sea level rise. But the intermediate timing after 2100, but before 2300 is maybe more complicated to get a convincing case for the high-end projections. But nevertheless, we may need to try this. And another shortcoming of the current study is that we don't provide regional information for the high end. That's in fact not too difficult to do, but it simply has not been done. So that's a thing we would like to pick up on, I think. And the main reason for that is that in the end, this is a product which is meant for practitioners, and they always need information for their local situation and not for the global mean. So I think there is a strong argument why we should make also the step to get high end at a more regional scale than just global mean. Well, and then at a bit more philosophical level, I think we can have a discussion on at which point of the understanding of the system do we believe that the physics are not sufficient, and where do we need expert judgment? Which things can we do without expert judgment? Because in this approach, we have expert judgment, which we, of course, would like to have as limited as possible, but the high-end projection for Greenland in 2100 is essentially, well, we have ISMIP and we have papers arguing that the mass loss can be a factor 2 larger due to circulation changes. So maybe high-end should be ISMIP times 2. And that is obviously an expert judgment. And I think maybe we should try to limit this as much as possible. So maybe we can come up with a different strategy for the Greenland contribution under a strong emission scenario, for instance. And another kind of related issue, which is open for discussion, I think, is that it is very important, I think, to organize expert judgment over time. In this case, we had 28 authors on board, but you can argue that this is only a selection of all the people in the community, and you can never be sure that this is the right selection which is representative for the community. And so the question is, how can we prevent bias such that a high-end projection, which includes expert judgment, is still a kind of community vision. So these are my concerns and thoughts for how, or points where we maybe can improve the current paper, the current attempt. But I'm happy to discuss these points, and I'm also happy to hear whether you see other points which are maybe not in this list, but which are still very valid to improve upon.
Thanks a lot, Roderik, for this summary. So I think we have 30 minutes, and if we need more, we will take more time to further discuss. I believe that, yes, we should try to make Protect helping on this high-end storyline. Of course, we have plans, and we cannot completely change our plans, but we can probably accommodate this plan to fit this question. And actually, I would have a first question to start the discussion. And Roderik, when you did that exercise, and you propose to maybe repeat it each 3 or 5 years. So what was the most missing things in the exercise, you think? What is missing really in the literature? What was more complicated to extrapolate somehow?
Yeah, I think the high emission scenarios for Greenland and Antarctica. For glaciers, there is not that much uncertainty related to the high end, I think, that because there is a reasonable set of models used for a reasonable set of climate models used for a reasonable set of glacier models. So you get the PDF reasonably constrained. And this will be done probably in the next iteration, maybe with another outcome, but there's not very much to gain. But for Greenland and Antarctica, there is, of course, the largest uncertainty. And yeah, I was actually a little bit surprised by the outcome that Greenland deviated so strongly from the AR6. And yeah, I think that is very strongly related to the fact that the AR6 on this point, the low likelihood scenario, relies very much on the structured expert judgment, which is way higher for Greenland than what the physical models provide us. It's about a factor 4 more than ISMIP. And constraining that, I think, is a very important issue. We have this argument of circulation, but in fact, the uncertainty related to albedo, I don't think we have really a handle on that. And so high-end Greenland scenarios, I think that's an important thing where we can improve upon. And yeah, as said, I mean, the intermediate scenarios are still lacking, I think. But that will be, I guess, the studies we will see in the near future will have that, I suppose. So that will be filled, I think. But there are limited studies for RCP 4.5.
So I presume that Protect will help in that territory.
Yeah, I mean, there are already a lot of things which are planned within Protect, which are very helpful for this exercise. So
that's great. Great to hear. Thank you.
Yeah, which is not coincidence either, of course, but so part of the issues will be resolved.
Perfect. Roderik, please.
Yes, it's thank you. Well, it's more to start the discussion also. If you look at the ABU-MIP experiment, which was done by Frank Patin and others, do you think that a revised ABU-MIP, which better takes into account the timing of collapse, could be helpful? Maybe not only for high end, but also to have upper bounds of sea level changes. What are your expectations based on that? And I suppose Frank will probably react on this question too. But I'd like to see what you think about it.
What we would like to do is an experiment which in a way originates from ABU-MIP, but which is a bit more sophisticated in the sense that we would like to determine for every ice shelf when it collapses, and then based on atmospheric forcing, ocean forcing, combination of atmospheric and ocean forcing, and define thresholds for that, and then repeat the ABU-MIP ID by removing ice shelves and then see how the dynamical response will be. And I think that's slightly more sophisticated than the original ABU-MIP experiment, because you then take into account that some small ice shelves which are not important for the sea level may collapse very early, and some other basins which are maybe very large contribute very slowly to sea level. So you get then a sea level contribution curve from every drainage basin separately. And I think that may be a step forward. But Frank may have other ideas on this.
I take the question in order. Mark, you're
Hi, thanks for a really nice talk and a really nice paper. I read it last week and really enjoyed it. My role is as the scientific leader of the Danish National Climate Atlas. And what we do in that is we present a whole lot of both atmospheric and ocean downscaled projections over Denmark. And many of our users that I've talked to are, particularly with sea level rise and storm surge flooding, are interested in the 90th percentile. They're not interested in the median. And when that then suddenly sets the cat amongst the pigeons in many ways, because how exactly should these types of scenarios be handled in that context? It seems to me that just taking the IPCC median confidence projections at face value is going to lead to a massive underestimation of the 90th percentile. So would you then recommend in that situation that we should actually be looking at the type of work that you're looking at as a more realistic estimation of where that upper end sits for use in adaptation planning?
Well, yeah, I think you definitely should not use the mean or the median. No. There are two alternatives. You use either the high impact, low likelihood from AR6, or you use this approach. And as soon as those approaches show divergence, which is the case for 3 of the 4 scenarios, then you have to think which one is more appropriate for your situation.
But if I can just expand on the question a wee bit more, you didn't name mentioning the median confidence upper bounds from the IPCC.
No, but we also did not address those.
No,
but if you want to use those, then you can use IPCC, and that's no problem. But
it's specifically from the stakeholders' perspective that I'm thinking. They want to know the 90th percentile, but then the question is, should you be looking at the median confidence processes or the low confidence processes?
No, I think you have to consider low confidence, because that's too far out in the PDF to rely on medium confidence processes only.
Okay.
So you have a problem there. And well, you mentioned it briefly, but that's another issue which we don't address here, but most of the stakeholders want to know changes in the extremes, in the temporal expression of the sea level, and not just the mean trend. But that's a different story, different discussion, I think, which is in the end for the stakeholders very important. But this does not offer a solution for them.
Okay, thank you.
Frank.
Yeah, I just pasted the link in the in the chat. In a way, a revision of ABUMIP or something intermediate has already been considered in the ISMIP6 projections 2300 for Antarctica, which are, I think now the results of this have been submitted. And there is an experiment on Antarctic ice shelf collapse, and if you follow that wiki link, you will see what are the specific ice shelves that collapse at what point in time. And that is already, let's say, a bit more advanced than the original ABUMIP, where all the ice shelves collapsed at the same time.
And I guess that's a direction which probably needs some further work, because there is, of course, discussion still on the thresholds, and I guess in particular on how to combine thresholds from ocean and atmosphere.
But I think that now many groups are also interested in investigating more closely effects of ice shelf collapse in ice sheet models.
Yeah.
So I guess that in a couple of I wouldn't say years, but I mean at least for ISMIP 7, there will be some more physical underpinning of such brittle processes involved, included in ice sheet models.
Yeah.
And thresholds that related to probably ocean and atmosphere temperatures.
Yeah, and that's, I would say, largely failing in the literature which was assessed over the last 2 years, and the first things are coming, and by the time that you have 4 or 5 papers addressing such a topic, I think it's valid to make a reassessment for a high end. So it's a matter of time, that's true.
Thank you, Robert.
Can you hear me?
Yes.
Okay. Thank you. I was just going to respond to Mark's comment about using this information. And I suppose I tend to sort of see this a little bit like almost an extension of the H++ approach that's been developed in the UK. Now that's one number, and here we have a series of numbers. So this is more sophisticated by emissions and time. But I suppose, again, I sort of, and I think when I think about the H++, I think the key question really is to think about a range of scenarios, Mark. I think, you know, you mentioned 90 percentile particularly, but I think I'd always recommend to look at a range of different scenarios, and then what, you know, and for the stakeholders, what numbers do they sort of bother them, if you like, you know, and with this high-end number, I think the primary use to me would be to avoid maladaptation, that you would probably adapt for a lower scenario, but you would think through, well, if this was realized, what would I do? And would that change my decision? And maybe in some cases like nuclear power stations, I mean, there may be the obvious case, they might well be actually interested in working at these sort of high-end values, and therefore there's more work needs to be done. I mean, they wouldn't take this at face value. They'd probably do quite a bit more work because we're probably talking about investing quite a large amount of money. So they have the resources, or like in the Thames Barrier, where, you know, in the Thames Estuary 2100 project, where again, a lot of money was invested in thinking this kind of issue through for a major piece of rather expensive infrastructure. So those are just my reflections. But I see it mainly as a guide to avoiding maladaptation at the time scale of interest and making sure that you're ready for the high-end case. That's all.
Yeah, thank you, Robert.
Mark, you want to elaborate?
And then I can maybe elaborate to what Robert said by saying that many of the stakeholders that I'm engaged with are the ones that are thinking on these long time scales, high robustness criteria. We're not talking about building a playground in front of down at the ocean. We're talking about these large infrastructure projects that really need to know this type of information. That was a useful way to think about it. Thanks, Robert.
Thank you. Paul, please, your question.
Yeah, it's great talk, Roderik. Thank you very much. You talked about covariance between the two ice sheets, and I realized I don't understand what you mean. So can you explain that, please?
Well, the question is, let's say that Antarctica is completely driven by ocean forcing and Greenland is completely driven by atmospheric forcing. Can we then assume that the Greenland contribution and the Antarctic contribution are both at their most extreme value? Because we don't know, we may not be sure that ocean forcing and temperature forcing are in line with each other.
I see. So it's because you're only talking about the high end scenario. It could be that Antarctica is high end and Greenland is median.
Yeah.
Okay, got you. I understand. Yeah.
And this may hold for the processes and for the climate. So in practice, if you do, we have had one paper a couple of years ago where you see that the covariance is pretty small. So that means if you make an estimate, an individual estimate for each ice sheet, then you should not assume them to be completely correlated.
Right. So in the case that the covariance is small, it's extremely unlikely they'll both be high end. So then,
yeah.
so then one of your estimates should be the median. So.
Yeah. So that
okay.
If that is correct, it means that you have to use the lower values of our estimates, in fact, rather than the higher values.
Yeah.
But I think a bit more confirmation on this topic is needed.
Okay, thank you.
Connery may comment on that as well.
Roderik, please.
Yes. No, I think you said it very clearly. So unless there is still a misunderstanding, but it was another question actually. No, you mentioned intermediate scenario, and in terms of intermediate scenario, so we are thinking all about SSP2/4.5 because it is relatively consistent with the current policies that are, let's say, in place or promised. And the point is, within this scenario, at present, at some point, we'll reach net zero. But the problem is that reaching net zero emission will be very challenging. And so what do you think would be the impact of having, let's say, a stabilization of emission at some point, but being very late in reaching net zero, meaning we reach net zero in centuries from now? Do you think it would affect a lot sea level projections, for example, say by 2030, 300 or things like this? Or do you think we can live with the present day scenario? So I'm asking this question because there is presently a discussion about scenario, what should be taken into account. And I have a really big question about this aspect, which is I no doubt that we can escape from the very high emission scenario with a 4 degree in 2100, but the net zero may be very difficult to obtain even in 1 century or 2 centuries from now.
Yeah, honestly, I fear that the ice dynamical understanding is not sufficient to answer that question in a reasonable time, because there may be tipping points or points where at least the change will accelerate strongly, and we're very uncertain where they are. And that holds for Greenland, but it also holds for Antarctica. So I'm not so sure whether we can answer that in short notice. But of course, further addressing tipping points for Antarctic and Greenland mass loss should be high on, or is high on the agenda, of course, of glaciologists. But I think the agreement or understanding is still limited.
Yes. So sorry, just to note, so what you say is that we may not be able to respond precisely to this question, but having more precise typing points with respect to global warming levels may help responding to that.
I think so, yeah.
Thank you.
Thanks. Robert, please.
Just following on, I think, yeah, because I mean, in the paper, the title has the word practitioners. So I suppose, I think Roderik answered it very well about but I think there still is, I think really, on the other hand, at least posing these realistic, if you like, scenarios of what might happen, I think are very useful, even if the science is going to be slow to answer them, and to try and see and to ask the question, what can we say about these middle cases? Because that's probably where we are in the real world. and practitioners would really like as much insight as we can get, but maybe it's not much. But at least I think it's important to ask these questions and just see what can be said, because as Roderik said with this exercise, I mean, you know, some of the insights to him were surprising, and yet it seems quite a sort of simple. It's a complicated exercise, but just by reviewing the information and thinking about it in a slightly different way, sometimes you can get some interesting insights that are quite practically useful.
Yeah, but I think the standard intermediate scenarios like 4.5 and 6, that's the thing which will be solved also over time, because our computing capacities are a bit better. So there's not really a constraint to do just 2.6 and 8.5. For many experiments, we can do 5 scenarios without any problem. So I think that will be sorted out, but the point made by Gonnery is also depending very much on the timing of when the maximum will be reached and for how long. And that's a further level of detail, I would say, where we are not really up to.
Okay, no further question? Yeah, Mark, please.
I'll have a go at one more. I'm just looking at your slide that you've got there, and you talk about intermediate scenarios and 2150, 2200, but you actually didn't mention the shorter timescales, 2050, as potentially valuable. And if you look at the low likelihood, high impact scenarios, they are already having a very dramatic effect in 2050. That's essentially a doubling in the amount of sea level rise. Is that also something that you've considered taking into the approach?
I'm thinking, I think we have had some discussions on it.
So sorry to make more work for you.
I'm not entirely sure why we dropped it. I think the reasoning was a bit that there is very little difference in scenarios in 250, but it's true that the low confidence processes make a very large difference in AR6. So I guess it's correct that this should be reconsidered, despite the fact that there is no difference between scenarios. There is difference between low confidence and medium confidence, and that probably requires further consideration. I think you're right, if that is what you mean.
Yeah, that's exactly what I was thinking. No, I thought that was very. That would also be potentially very interesting, because that's the time scale on which I'd say the majority of the stakeholders I engage with are interested in.
Yeah, I see the question from Philippe is also valid. But in our approach, we did not really make a time-dependent high-end sea level rise projection. But clearly that should also be done, and that may partly solve implicitly also the 250 issue.
I have another question. We did not speak a lot or discuss a lot about expert judgment, and it's a completely open question, but do you believe it would make sense to have expert judgment not on the amount of contribution from Antarctica or Greenland, but rather on the processes to help constraining the parameterization in model based on high-end estimation of the processes by the experts?
Yeah, I think that's definitely needed. If you take the Greenland case, I already mentioned albedo, and I think we're pretty uncertain about the uncertainty which may be introduced by uncertainties in the albedo parameterizations, which is in models. I think they're working on it, but it has not yet been published in all detail. But I mean, within Protect there is work ongoing there. Oh yeah, the expert judgment is not just on numbers, but it's also on processes.
Okay. Is there other comment or question in the audience? Eiko, maybe you want to comment?
I was just a quick comment. I think that in this traditional expert judgments, basically everybody that has ever published anything on sea level is a sea level expert. Whereas when you focus on specific processes like albedo, then there's kind of a much smaller range of people that really worked on that and have a clear understanding of what that means. And I think that could help to make these expert judgments more reliable and trustworthy.
Yeah. Yeah, that in a way comes back to the last point, how you organize it over time. Which people do you need to do it another time? And maybe we have some gaps in the 28, and maybe you should come with 28 others covering really all the processes which matter.
Frank Poller, you have a question, please.
Yes, thank you. It's maybe a little bit off, but just to ask for the high-end scenarios, is there anything we could learn from the geologic record? So going back a few million years?
Mm-hmm. Personally, I think yes, but the problematic thing is that the current set of papers we have on paleo sea level rates provide limited constraints, because many of the studies are focusing on high stands, for which you have thousands of years to equilibrate to the high stand, and the high end is very much a transient concept. So I think that we considered geological literature, but currently it's not providing enough constraints. Having said that, I think there is a lot of development ongoing there as well. So I foresee that this is going to play a more important role in the discussion.
Thanks.
Is there a last question? It seems not.
Yes, maybe one.
Oh, yes, please go ahead.
I'm coming back to the 2050 question actually, and I remember at the beginning of Protect, and we said that if there is a high climate forcing, then the first response from Antarctica would be more precipitation and accumulation of snow, and then processes like MISI or maybe MIKI could take place, and there would be an acceleration of sea level rise, but after 2050. And what we see in this chapter 9 of the IPCC is, as Mark said, relatively high potential sea level contribution in 2050. So the 87th percentile is 40 centimeters for the low confidence scenario. And I wonder whether it's, let's say, to me, it's like, we have lost we have lost confidence in our previous statements, because before that report we actually said that by 2050 the likely range of the IPCC projections were quite fine actually, and this is after 2050 that we have a risk of rapid sea level rise scenario. And I feel that now we cannot exclude this high-end scenario as soon as 2050. And I was wondering what you think about this. So I know what is based on. I know the paper from Bamber. I know the Mickey papers, but I would like to know whether you think that this process that we had identified earlier, the increase of precipitation over Antarctica, should be, well, is more doubtful now than it was before, or if we, what is your opinion about that?
I fear I don't have a full answer, but if you look to the slide, you see the very large difference in 250 between all scenarios and the low confidence scenario. And this does not have anything to do with precipitation increases. So I'm not so sure how one can get such a high value in 250 already. And this is also not related to collapse of ice shelves. And so the Mickey is not playing a role here. In the recent Continental and Pollard paper, ice shelves also only break up starting around 290. And the sea level contribution from that is all concentrated after 2100. So this discrepancy between low and medium confidence process is also not related to Mickey. But so I'm a little lost in what causes the difference, but it's not in the suggestions you have, I would say. Maybe somebody knows, but.
And in your study for this period, presumably won't it be Greenland that would matter more on the island than Antarctica on short time scale?
I'm not so sure, because the difference here, if I look, is already 20 centimeters between medium and low confidence in 250. And that's more than the entire contribution from ISMIP over the whole century. So
that's true. True. Robert.
Well, I was just going to say, I mean, and with these short term, I mean, if we were on that trajectory, we're going to measure it, aren't we? We'll quite quickly see that was happening. So so it's not really, this is almost not in the realms of prediction. This is almost in the importance of monitoring and maintaining all the frames of reference that we have to see what is happening. So yeah, I mean, I tend to, my view is, I suppose I tend to think these high end, probably that is bringing it forward a little bit myself, but I'm not really an expert on these things. So I will defer to others.
Is there last comment? I saw Mark has written in the chat that is check on the NASA AR6 tool, but please comment.
Yeah, while we were having that conversation, I had a look at the NASA tool, and the numbers that I'm getting out of that are nowhere near as dramatic as the numbers that we're seeing there on that in that particular figure. So I'm sort of even more confused. I agree that I know that the time difference is they have different baselines. It's what Gonorrhea is pointing out. I realize that, but that shouldn't affect the uncertainties, and the uncertainties there are much greater. I need to do some more reading, I can see.
But the NASA sea level tool, my understanding is that this is the medium confidence.
No, you can also get the low confidence out of it.
Oh, and that's what you took.
Then that's what I took, yeah.
Yeah, I don't know.
Okay. Last comment or questions? Seems not. So, Roderik, thanks again for this nice presentation and help, and this helps to discuss further. And we will continue this discussion within Protect for the coming months and years, I'm sure, and try to adjust our plan to help improving the answer to these huge questions. So, thanks everyone. enjoy your afternoon.
Thanks
And,
everybody for the participation.
Goodbye.
Bye-bye.
Goodbye.